All right, should be recording now. All right, then I will go straight to into the paper. Okay. All right, question 1. Just in case of any question, please type through the chat box or do the virtual hand raise. Then, yeah, then you can type your question in the chat box. Just the hand raise alert me. Then you can always type the question paper in the chat, your question in the chat box. All right. Okay, cool. So question 1. Assume question 1A. Assume you have a class which contains only primitive data members, that's no objects or pointers or arrays. Which of the following pairs of operators will operate correctly on this class? So we are looking at a class with primitive data types. There's no objects, pointers, arrays. So when we look at A, part A has the dot accessor, which we can always use to access functions within that class. Say we have no specific objects, no pointers, no dynamic memory allocation. We can use the dot to access various properties or also functions. Then we can use the assignment also to assign values to each other. Then option B says addition and minus, of which I don't see use for in this case, so I don't think B is correct. Then C is the asterisk is usually for accessing pointers, so that's already wrong. Then the slash, the division sign, that's wrong. D, reference sign, but we are not working with any pointers or arrays or any objects, so we are not going to try to get addresses, memory addresses, and the sign. Then E is the not sign, the negation, the sign that's going to negate equals, not equals to that negation sign. Then the modular sign, which we don't need. So the answer is going to be A. The answer is going to be A. We have the dot, which we can access properties and functions, and the assignment, which we can then just use to assign values. All right, then what's the minimum number of constructors a class can have? Okay, A is 0, which is right because we can have we might not explicitly create constructors, and then meaning the application will use default constructors. The class will use the default constructors, so we can have a minimum of 0 really, where we'll use default constructors. Meaning B, C, D, E are wrong. All right, then 1C. So for efficiency reasons, objects with large state are often passed by const reference. That's true. So the reason we pass by const reference is we are const to make them immutable, so that we don't change those values, so that they're just I usually look at them as immutable borrows. We are borrowing the value and it's immutable. We are not changing it, we're just making use of it, its properties, but not change it. So const makes it immutable. Then reference, we're just getting a reference of it. We're getting it from its address. We're not making a copy of it. So that's true. It's way more efficient than we having to just call the value, pass value, then make a copy of the value. And if it's a very big, large, as you can see, large state, if it's a very big value, that's a lot of memory being wasted. A const reference, that's true. Then D, which of the following is known as the scope resolution operator? You remember the scope resolution operator with namespaces and classes. When we are accessing properties, functions, and namespaces, we use the scope resolution, which is A, the 2 full colons, A. So A is correct. Then question E, what's the correct return type for a destructor? Remember, your destructor is not really returning it, it's just deallocating the memory. So so when we look at the option, I've already given you the answer, it's not really returning anything. So let's look at the other options. B, void. We don't necessarily have to say void. Remember, our destructors, we use the sign to show that, oh, this is a destructor. Then void pointer, no. Void reference, no. Int, no, it's not returning an integer. So correct is none, so none of them. It doesn't really return anything. Okay, then question 2. Let's go to question 2. So name 3 kinds of relationships that exist between classes which are found in object-oriented design. So 3 kinds of relationships. So I will look at hazard relationships. We have your hazard relationships, which are basically, which can be broken down into 2. We can have 2 hazard relationships. That's your you can have composition where something is part of something, it's composed of something. Okay, hazard is basically containment. Something is contained inside of something, but you can have 2 types of containment. Have one whose life cycle is managed by the class that it's contained inside of, and the other where it's independent of it. So the first one is composition, where the life cycle is managed. Like we gave you an example of, let's say a human body has an arm. So not really, okay, that's not very, that's not very, that wouldn't be the best example, because even without an arm you would survive. Let's think of example of how composition. Human body is composed of heart. Imagine we have a heart class, then we have a human body class. So that's sort of composition where the life cycle of one is managed by the other. Without it, the other wouldn't survive. Then we also have, you know, association, just has a association where association aggregation where we where the life cycle is not really managed. Like let's say a stadium has funds, but a stadium can still live without funds. I mean, yes, it's an advantage when there's funds, but it's either or inheritance generalization, which is basically various specialized or specific classes at the bottom. So those are the. Then part B, question 2, part B, class. All right, so basically an object was giving me. Everybody hear me loud and clear? Can everybody get me well? Just do the hand raise if you can hear me loud and clear. All right, cool, that's fine. That's fine, because my network is notifying me that. All right, thank you. All right, cool, thanks. Okay, so what's the difference between an object and a class? So an object is basically an instance of a class. It's created of a class. Then a class is just a template or a blueprint of a class. So it's a structure of what a class should look like. Then using that structure, we can define a specific object. All right, so let's go to C, structures and function pointers. Okay, let's go to C style structures and function. All right, so when we look at this code, the following example is a subset of code which makes use of structures and function pointers to implement the game from the first semester. So we have a namespace called gamespace. Then we have an array of characters called array symbols that have various characters. Then we have something there, and the comment show that it's an enumeration for directions, north, east, south, west. So that automatically gives us the answer for A. So A is enum. All right, then we have a const int called rock chunk, which is 10. To B, so B says this is a pseudo class for game. So just by virtue of looking at the word pseudo class for game, we have structures. So B is going to be struct. B is going to be a struct. Then those are the various properties inside of it. You have an array for the world state. size of the array, rows, columns, and the player location. Then you have function pointers, which are pseudo member functions. You can see them inside. But the structure of function pointers, it's the return type, which in this case is void. Then in brackets we put function, but it's a pointer. So that means there's a pointer sign. So C means as C is going to be an asterisk, which is for pointer and asterisk. All right, then the arguments, uj game pointer object this. Then D is basically an implementation of the make world, which allocates memory, which creates a pseudo, basically allocates memory and creates the pseudo object. So make world, at the end of the day, make world is going to return a pseudo object uj game. So D is going to be uj game pointer with a pointer. I think I will need to let me write down. Let me open Notepad. Okay, we'll just go back up. Okay, A was supposed to be an enum, because that's an enumeration. Then we went to B. B is our struct. And C is going to be a pointer, is an asterisk, sorry. Then D is we're allocating memory and returning a uj game object. So it will be uj game pointer. And E, what's E going to be? So E, we are instantiating from FreeStore, we are allocating memory. So we need the new keyword, the memory for uj game, a new pseudo object. So that's going to be new allocates memory. So it's going to allocate memory on the heap. Then F. So after we allocate memory, we set the value of the rows, columns, player row, all inside of, because this is a struct. Then we'll allocate memory for the game world, which is a two-dimension, the integer, the rows, then the columns. Then once we have done that, we place it's not space, it's a goal, then plus the goal. Then after that, we now need to point functions, because remember these are function pointers, so we need to point them to their actual implementation. So F, that means F is going to be, because it's pointing to the implementation of, so F is going to be show. That means F is just going to be show. Then G is pointing to the implementation of make move implementation. So that means make move. All right, GH. So once we are done with that, then we need to return something, because remember, we return a pointer, we return a pointer of uj game. So that means H is going to be the keyword return. Okay, so that's that function. Then now this function is deallocating memory, freeing storage. So we loop through our rows, delete each row. Then after that, we delete the entire object. Then we have to delete. No, we delete the last array. Then actual object. And after that, we have to set it to null pointer. So I is going to be delete. Then J will be null pointer. All right, so any questions as regards that? All right, cool. So we'll proceed. That was 4. So we shall proceed to 5. Okay, so let's take some other question. Okay, not a question. All right. If you have a question, just type it in the chat box. It's easier. All right, cool. So let's proceed with object oriented. I think there's there's a lag or something because I keep getting these notifications a little. But you can type in the chat box if you have a question. All right, so let's go to question 5, which is object-oriented programming. All right, composition and delegation. So that's object-oriented programming. All right, so UJ flag has a UJ image whose life cycle it manages and to which it delegates its operations. So UJ flag has a UJ image and it manages its life. All right, so when you look at this code, we are going to this is the UJ flag and it has a image, so we need to include the UJ image. So I think if you're raising your hand, just type in the chat box. Just type the question in the chat box. If you have a question, just type it in the chat box. If you have a question, please type it in the chat box. I think there's a lag. There's a lag with the internet. All right, if you have a question, please type it in the chat box. Oh, really? Chat is off. Someone says the chat is off. That is strange. That is really strange. I do not know how to configure the chat bit. Honestly, I do not know how to. Okay, all right. So maybe you can try. Okay, you can try. Whoever has a question, you can try maybe talking, just asking your question, and maybe unmute your mic and try to ask. Because I do not. Problem could be chat box. Maybe try unmuting your microphone and talking and asking the question. Wow, chat and mic are not working. Okay, that's not good then. Okay, for now, yeah, you can just you can send me the question on Discord, then I'll answer you. Sorry, apologies for that. You can just send me a question on Discord. Try to read it and respond and ask and read it out loud so that everybody can know what the question is. Then you can answer. All right, so send it on Discord, then I'll be able to respond. Okay, so question 5. Right. Okay, question 5. So question 5 is composition and delegation, object-oriented programming. So the UJ flag has a UJ image. So that means this is the UJ flag file, probably .cpp implement or .h, one of the files. So we need to include the UJ image file because its image is going to be used. So A is going to be hash include preprocess. All right, so what are they called? They're called macros, something like that. Yeah, so that's hash include. Then B is going to be, since this is object oriented, B is going to be class. Then C is going to be, now we are working with private properties. So C is going to be public. Then when we go to D, so this is our default, our parameterless constructor. This is our constructor with parameters. Then this, as you comment, is a copy constructor. So remember, when we are copying, we use a constant reference. So D is going to be const, E is going to be the reference sign. Okay. These are accessors. We are trying to access the rows, columns, and the picks at a certain index. We don't want to alter anything to be constant. Then G is a destructor. So remember the tilde sign. Nothing you return, it's just a tilde sign at the beginning to show that it's a destructor. Then H is going to have data not visible from our class. So that means not visible anywhere else. So that means that's going to be private. Is a UJ flag has a UJ image pointer. So remember UJ image pointer. So that means UJ image pointer. So that's going to be an instance of it called object image, obj image. Then it's, yeah. So J is basically delegation. So we are going to call this UJ image pointer and try to access the function from it. And remember, it's a pointer. So in order to access, we use that arrowhead. All right, so those are the answers for question 5. Okay. All right, so that's question 5. So sorry, I don't know why I called it question 5. This was question 3. That's question 4. All right, okay. So to be a UML diagram. So I'm going to use DR to draw this diagram. But before I start drawing, we're going to first go through the explanation of the scenario. Then we try to figure out the keywords, because I remember someone last time asked about how do we identify the keywords, know what's going on. So we'll try to identify the keywords and then try to come up with this visual. We actually draw the UML, we'll come up with some sort of visual representation of what the UML might look like, and after I draw the actual UML. All right, so all right, so we say a shape 3D, a shape defined in terms of x, y, and z integer coordinates. So it has a position, but that in terms of 3 different coordinates. So you would instinctively think, okay, there's some sort of struct, because a struct is going to create some sort of data type. So that's going to be our position. It's going to belong to a certain data, 3 terms, which are the x, y, and z coordinates. So I'd be thinking around a struct, and there's already hazard here. So there's some sort of containment. So inside of that shape 3D, there's something that has an x, y, and z value. So I would think something like this. So this is just drawing stuff as I think, just have a rough idea of what's going on. So there's a shape 3D, right? So there's a shape 3D, some sort of position. So there's that hazard relationship. So which is that thingy, this weird. But we still don't know about the life cycle. So I'll just keep it. I'll keep it like aggregation. Then it has some sort of position. So I'm going to think around the struct. This is just me thinking out loud before I come up with the actual solution. X, Y, and Z coordinates. So it's called okay, so I'll think, all right, so there was a position. So that means position, right? So type position. Okay, then okay, what's in the position? In addition, the color, right? It has a color. So you remember containment again, but now this is something defined in terms of red, green, and blue components. Remember, this one was defined in terms of X, Y, and Z integer coordinates. In terms of red, green, and blue components whose life cycle is it manages. Now you're seeing it manages life cycle. So now think that's composition because it manages its life cycle. So let's see. So there's going to be a color. Color is going to have blue components, and its life cycle is managed by this class. So okay, I think since its life cycle is managed by that class, I'll just fill this black. Then all right, so this is in my head. I'm just sort of trying to bring everything together based on what I've read so far. All right, so a shape 3D can draw itself. So a shape 3D can draw itself. So let's say it has a draw function, right? It can draw itself. It's a function, so I'll just add to differentiate functions from properties. So it can draw itself. Both shape 3D and color encapsulate their data behavior. So encapsulate their data and behavior and have suitable constructors and distractors, while position is simply a collection of integers. So this comes to show that it actually justifies what I was thinking initially, that position was a structure. So shape 3D and color encapsulate their data and behavior, meaning they are classes, and have suitable constructors and distractors. Position is just simply a collection. So position is going to remain a structure because everything is accessible. It's just a collection of stuff. And then these encapsulate, so they are going to have constructors, distractors, besides the other properties. So I'll just say constructor, distractor. I'll just put brackets just so I know these are sort of functions. All right, okay, so that's what I have at the moment. So then yeah, it does have a draw function, which it does by itself. Shape 3D has a draw, which it does by itself. Then all of Shape 3D's data must be accessible from any classes which are derived from it. So any classes that derive from Shape 3D should be able to access its data. So that means I can't have its data as private, but I'm going to have its data as protected. So at any derived classes, be able to. So I'll just put a note there, protected. So that its data is protected because any derived class can access any of its. Then we continue and say a pyramid is a kind of shape 3D. So a pyramid is basically inheriting from shape, right? So that means it's a kind of shape 3D. The pyramid is going to be a kind of it. So there's a bit of inheritance there. Pyramid, not mind. Pyramid, which is defined in terms of its base length, base width, and height. So it's going to have its base length, width, and height. Base length, width, height. All right, so that's what a pyramid has. A pyramid is derived from, this is really horrible drawing, but it's just a rough. I will then do this there. All right, so that's I think someone's microphone unmuted. Something push up the name of the pyramid. So I'll just put it at the top. All right, so pyramid. Okay, that's my pyramid. Okay, then is a kind of shape 3D. So now besides the pyramid, there's also going to be a sphere. We'll just add a sphere here. So this you could do, I don't know, with your pen, pencil, whatever, just to have an idea of what's going on, which is defined in terms of its rate. Both redraw, this is overriding. They're going to override that behavior, that draw behavior. Yes, then they both override the draw behavior. So we are thinking around to virtualness to the draw function. All right, cool. So I can then be able to open up my dia and draw it out. Okay. Okay, cool. So we have an idea of what diagram we need. So first we have a class called I will build this from the bottom. It has two things inside of it. It has a position and a color. So I'll start. So I'll move position this side just to make it special. Let's call this position. It's a structure has public attributes, and the attributes are going to be x. Second one is going to be y. So just coordinates. All right, so that's our position. Then so that class is going to be called color. Are going to be red, green, blue. Okay, then remember it has so let's go color. I'm just being as generic as I can. I don't. Okay, so let's let's say properties are public. Both color, whose life cycle it manages. They don't talk about. Imagine. Let's keep them all public. Then the other class is shape 3D. Shape 3D is going to be composed of okay, it's going to have a constructor, destructor, so I'll just call shape 3D. A property which, and remember all its okay, let me a virtual function called draw needs. Then those are all the, they are going to be protected, because remember, every derived class needs, so they're going to be protected. So the first property it's going to have is the position, which is an XYZ. So the name, let me just call it pos, it's going to be of type position. And since the derived classes have to access all these, I make them protected. Second one is going to be, I think that was all. That was all actually. Encapsulates that Chef3D has a position. It, in addition, it has a color. Okay, yeah, it does have a color too. So that's going to be, let me put cool. It's going to be protected. It's going to be of type color pointer, because its life cycle is managed. So it's going to be, let me also use underscore here. All right. Okay, so then, yeah, that should be our shape 3D class. So let's build relationships here. Let's bring these things. I think that's a wrong one. Let me see, it's the wrong one. Yeah, I'll just do this. Delete. How do I delete it? Delete the entire thing. Okay, it's this. Okay, so let's build the relationship between our shape 3D and our position. That's it. Then I'll just copy this. Build the relationship between our shape 3D and our color. That's composition. So I need to change that to black. So I will just go composition, apply, okay. Then now we need the inheritance. We need our pyramid and our sphere classes. So I will put that down there. And I'll put that down there just to make it pretty. Then that's going to be our pyramid. I don't know, keep writing mint. Then the attributes it's going to have, the private attributes it's going to have. Those are operations, those are attributes. I think I altered that. No. Did I? Yeah, I think it's fine. I think. Okay, so the attributes, I think I made a mistake here. Color and position are not operations. They are attributes. I interchanged attributes and operations, apologies. Operations constructor, which is shape 3D. That's why I didn't put the brackets. I was wondering why. Shape 3D. Then the other is going to be virtual draw. It's going to be void type. All right, so the attributes were the position of I put underscore pos of type position, and that's going to be protected. Then the other was color, type color pointer. That's going to be protected. Then that goes away. Yeah. Yeah. Apologies for that. Okay, then we have our pyramid. Our pyramid. So its attributes are the base width, the base length, base width, and height. Let me just confirm. Its attributes are going to be the base width, and height. imagine all are integers. Base length, which could be an integer. I could keep them private. Base width, int, private, height, int. So those are the attributes. Then the operations, it's just going to override the draw function, which is void. All right. Okay. I think someone has a question. I see. Okay, you can. Is it possible now to unmute your microphone and maybe speak? If just send me a DM on Discord, and I'll read it out. Because I think the chat is disabled. Yeah, you can send me a DM on Discord because the chat is disabled with the question. Okay, then what are we looking at next? We are looking at our sphere. Our sphere only has one property, which is the radius. It has one additional attribute, which is the radius, which is an integer, and I'll make it private. Then the property it's going to have is going to be, it's going to override the draw function. So let me look at the question. If there's anything that I've missed, because I remember live. All of Shep3D's data must be accessible from any class right from it. That's why I have that's why I make them protected, so they are accessible from any class that derives from it, the sphere, and you can access. I'm trying to see if there's any need for getters and setters. I do not see any explicit need for that. Yeah, I think that's it. If you have any question, let me draw the inheritance here. If you have any question, please just sorry, we don't have access to the chat, so just send it on Discord, then I can be able to. Yeah, so that the Shep3D has color, has position, then sphere inherit from it, override the draw function, constructors, no construct, just a struct. Yeah. Okay, if you have any questions, just type, but I'll be able to see it and respond. I'll be able to open this and go back to wherever and explain it to you. All right, cool. So let's look at the second paper, which is paper B of the same year. It's just paper B. It's paper B 2017 semester test 1. Okay, all right. So let's go through it. Okay, question 1A, which of the following is not object-oriented? Not object-oriented. So C++ does support oriented programming. Then C does not, because remember C we had to CU to do pseudo objects and whatnot. So C does not support object-oriented programming. VB.NET does support object-oriented. I read up about OO-Camel, which is I think an object-oriented preprocessor, something like that. So it does support. Then Python also does support object-oriented programming. So the answer here, the definite there would be B, which is C, which is the C programming language. Okay, then let's go to question B. In the programming style used in computer science 1B, member function is named in the style get attribute name. What type of member function? So remember getters, setters, get, set, getters, access, they access something. Muted, they set something. So the answer would be A, which is accessor, called getting. Mutator, this is not muted, getting. So mutator would be wrong. Constructor would be wrong. Constructor is the same as the class name. Destructor is the same as a class name with a tilde at the beginning. Utility, no, this is not a utility. This is a getter. It's an accessor. So the answer is going to be A. Then without doing any additional work, any newly created object can be compared with another using the operator. The answer would be false, because by default the assignment operator wouldn't be objects. It wouldn't be able to draw a comparison between objects. So in order for you to make it compare to objects, overload that operator and then explain to it how you compare the two objects, so that it figures out how to objects. So you will need to overload. So the answer here is going to be false. Then D, following is used to declare a destructor. So remember your destructor, we are just from talking about destructor, it's option A, tilde. Use this sign to declare a destructor. This sign, then the name of the class or destructor. These are wrong. Question E, which of the following is used to both dereference and access a member through a pointer? So remember, I'm going to erase this. If we have a UJ image pointer called, let's say, object image, it's equal to new UJ image, we have a constructor and parameters. Imagine we have this object called object image, then it has a couple of functions, right? So we are trying to access, it has a function get attributes, right? Get rows, let's say get rows. So remember, in order for us to call the get rows, we call that we use that accessor. Remember, it's a pointer, so we use this accessor, then we call our function, let's say get rows, right? So that is going to call the function get rows. So it has both dereferenced and called the member function. So to explicitly explain what goes on in image, which is a pointer, by putting that pointer sign at the front. Then once you dereference it, you can, what if it's not a pointer? Okay, I will answer that. Then we dereference it. Dereferencing and the accessing, all of it has been done in this one C. So someone has asked on pointer. Well, if it was not a pointer, if like, let's say object image 2 and it's not a pointer, then if it's not a pointer, then I would just use the dot sign to access it. I'll just use the dot sign, then get rows. Yeah, so I'd use the get sign, the dot sign, then get rows. But now that it's a pointer, because the question explicitly says the following is used to both dereference and access a member of an object through a pointer, and that means you have a pointer. That the answer is going to be the arrowhead, which is C. Okay, so question 2A. What are the 3 keywords used to specify visibility of a member from outside its class? What are the 3 member access specifiers? So that's going to be 3 3-member access specified, providing visibility outside of that class of properties and functions outside of that class. It's going to be public, which means everything can access from that class. Protected, meaning only the derived can access. Then private, meaning no other class can access it. So those are the 3 access modifiers: private, protected. Okay. Name 2 kinds of inheritance which are allowed in the C++ programming language. So inheritance, remember, inheritance is your is-a relationship, is some kind of is a type of. So there's going to be multiple inheritance and single inheritance. Remember I gave this example, multiple inheritance, like if let me just show you both single and multiple all in one diagram. So I say, imagine we have a person, right? All of us are some sort of person. So we're inheriting from, so there are many types of people in university. We have staff and students. So let's say we have staff. The type, there's something unique about staff, there's something unique about student. So you see, this is single inheritance because each of them inherits from one person. So it's the same as me just saying, which wouldn't make sense, but anyways, just to show that single inheritance, that a person, then student. So it's single inheritance because I'm inheriting from one class, right? So each of them inherits from just one class. So that's single inheritance. So that's single inheritance. So that's supported in C++. But what if now with a TA, like a teaching assistant, right? Teaching assistant, who shares properties of both a staff member. They share properties of both a staff member and a student, because they are a student, but they're also a staff member. Then they properties that are unique to a student and also certain properties that are unique to a staff member. So that creates multiple inheritance. So this is an multiple inheritance. Teaching assistant is inheriting from multiple classes. So that's multiple inheritance, which could potentially result, remember the diamond problem and stuff like that. Yeah. So that's single inheritance, multiple inheritance. Okay. All right. So so those are the 2 types of inheritance that are C++. So let's look at the code. I'll open my notepad again so that we can keep track of the answers. Okay, all right. So C style structures and function pointers. So C style function pointers. So the following example is a subset of code which makes use of structures and function pointers to implement an RGB-based image. All right. So this is a header file which includes string using namespace std, a namespace called image space. So a UJ color record structure. So this explicitly tells us that this is a record structure. So in order for us to define a record structure, we start with struct. So A is going to be struct. All right. So it's struct UJ color, then unsigned, short, green, red, blue. All right. And a UJ image pseudo class. So this is a pseudo class. Remember, it's not a class, it's a pseudo class. We are trying to mimic a class. So remember, when you create your pseudo classes, it's going to be structure. So, and remember, A is the same answer as A here, so it's still struct. It's still struct. Then B is going to be a dynamic 2-dimensional array point of UJ colors. So you see, dynamic 2-dimensional array. So you can see 2-dimensional array by the 2 pointers called, but it's of type UJ colors. So that means B is going to be UJ color. All right, then we go on. Okay, it's a pseudo object, right? So B is going to be UJ color. Then These are the properties, rows, columns, then function pointer. So remember with function pointers, it's the return type, then a pointer to a function. So C is function, so it's an asterisk because that's a pointer to a function. Okay. And then D is going to be object this. So this basically this object is going to be this type, which is a UJ image pointer. So D is going to be UJ image pointer. All right, so that's what we are passing as an argument. Function pointer, set image color is a function pointer. ppm is a function pointer. That's why they all have an asterisk at the front of the function name. Then the argument that's passed in is going to be pointer. All right, then we go to E. E is going to allocate memory. So when it allocates memory, it's going to return a pseudo or in an instance of UJ image. So it's going to return again a UJ image. Then F is freeing memory. So in order for us to free a reference pointer, so that's going to be that for deallocating memory. All right, so cool. So to ppm, this is our keep concatenating. Remember here string, so we're just going to keep concatenating. That's why I say plus equals plus equals plus. So remember when we are working with an RGB specify P3 at the top. Let's put this GH. Once I get the P3, then I will put the, add on the rows. I'll have to go into a new to add a new line. The columns, rows, new line. Then after that, we have to take the maximum intensity. That's going to be plus equals, that's going to be 255, so we can pass it as the new line. This is me being very explicit, trying to give the answer that's expected. So all right, so we've added a 255, jumped onto a new line. We load the various color intensities. Then we go down to the main function. So the main function is creating a pseudo object. So when we are creating a pseudo object of object blue, remember UJ image has a function called make image, right? That returns a point image. This returns a pointer to UJ image. So make image takes as an argument the rows and the columns. Two rows and columns, two arguments. So I is then going to be make image. J, once we make the image, then we create a record structure blue, set the color to blue, then this out to ppm. Remember your 2 ppm function is a function of this, and was 2 ppm, and it's a function pointer, so we'll just use the arrow. Okay, so that should be the correct answers for question 3. All right, so let's go to question 4. All right, so question 4 is composition and delegation. So A UJ image has an image inverter to which it delegates its invert behavior, right? UJ image has an image inverter. We can see we include a UJ color.h, also means there's some bit of color included. We need to also include the image inverter. So A is going to be an inclusion of image inverter. Image inverter.h, that's going to be A. Then B is going to be, we need have a forward to make a forward declaration of our image inverter because we haven't yet so we need to make a forward declaration of it. So so that's going to be class. Then is going to be declaring a UJ image class. So in order for us to declare, we also need to call again visible out. These are properties, not properties, sorry, methods visible class. So that's going to be public. Then E, all right, constructor parameters with parameters, then our copy constructor. So we pass a constant reference, mutable. So that's going to be a reference. Yeah. We have our getters, we have our setters, then we have our class level constants. So that means we have to make them static. So F is going to be static. Then after F comes G. So these are not visible outside the class. They're not visible at all. So that means they have to be private. They haven't said anything about them before in the derived classes or anything. They just say they are not visible outside this class. So that means they're private. Then we have these private properties, init, which allocates memory, checks range. This stores out two-dimensional pixels, rows, columns. Then we need to have an image inverter. So remember, image inverter is a class, so an instance of it whose life cycle will be managed inside here. So H is going to be that class image inverter. HI. So I, this is a function that inverts, that's going to implementation of the invert function, which gets inversion to the inverter object. So in order for us to use it, this is an implementation of it. So we need scope resolution operator. Then lastly, we need to be able to call that invert function. And remember, inverter is a pointer, so that means we need that arrowhead. So those are the answers for question 4. If you have any questions, just type in this code. So let's go to the question 5, which is an object-oriented design, which is basically UML diagram. So I'll do this the same way I did the other. I will first draw a very rough copy of what it might look like before drawing it on there. That makes it easy for me to know what I'm doing. It gives me an idea of what I'm doing rather than going straight here and changing things here and there. All right, so I will open my my Paint. All right, so okay, let's start. A pixel can be represented using different techniques, but all pixels have a row and column value and the ability to display themselves. So that already says there's going to be different types of pixels. So it's basically already spelling inheritance, because a pixel can be represented using several different techniques, meaning there are different ways you can represent a pixel. So that intuitively should tell you that there's a bit of inheritance in there. But then all pixels have rows and columns, meaning that's a common property, rows and columns, and the ability to display. So display is also a common function. So just based on my intuition, I will draw that. I'll edit it in case of anything. So I'll just say, okay, so a pixel is going to have row and column, right? And also the ability to display itself. So that's some sort of function. Okay, so let's go on. So the row and column values must be directly visible to all kinds of pixels. So it's directly visible to all kinds of pixels, whatever pixel inherit from it. So this spells like I'm making protected because it's visible to whatever is derived from it. But other classes will have to use appropriate member functions. So that means it's protected. Then I will need to implement other appropriate member functions so that getters and the classes to access. So that means I'm going to say, I'll just notify here protected. So that whatever inherits, whatever it can access those properties. But then they say, but other classes will have to use appropriate member functions. So let me just say getters too, setters too. I don't know if I'll need them, but let me just. All right, let's say an RGB. Now you see, now they bring what I was thinking. An RGB pixel is a pixel. So that's inheritance. It's type of pixel. RGB pixel is a pixel, which additionally has a red, green, and blue integer color component. So they tell me an RGB pixel is a type of pixel. So that means my intuition was right. There was inheritance, and the derived class would be RGB pixel. And in addition, RGB pixel has red, green, and blue integer properties. So it's going to have int, red, write them down like this, right? Okay, so it has those properties. Then a value pixel, like that's black and white pixel, is a pixel. So that's again inheritance, which has an intensity, an integer intensity value. So that's again BW pixel with an intensity value, that's an integer. Right. Okay, cool. So we know that now. Every pixel implements its display behavior differently. So we are overriding display. Remember, display was a shared function. Now it's overridden, it's being implemented differently. Display differently. I don't know why I always add the E. Oh, God. Okay. All right. So that's display going to be overridden. Then they say an image. Now I think different class because we haven't across image at any point. An image has a set of pixels and it delegates its own display behavior. So now we are thinking, oh, an image. There's a new class called an image. And it has a set of pixels. So we are thinking, okay, maybe it has a list of pixels or something. Many pixels. And it delegates its own display behavior. The image manages the life cycle of the pixels. So that means the pixels are created by this image, and it also has its own display, which it will delegate then to the pixels. All right, so it manages the life cycle. So that means that flat fill it with black, flat fill. All right, so that's, I'll just draw this. I'll flat fill it. All right, so something like that. So that gives me a rough idea of what I'm looking at. So now let me go to the open and try to draw this while still looking at the question paper to just make sure we're doing everything right. Okay, so that's there. I'll raise this. Let me just erase this. Okay, so it started out with a pixel. I'll just overwrite this. I'll just write different things. So they said a pixel has rows and columns as its attributes. It has rows and columns. A pixel has a row and a column, not rows and columns. They say pixel has a row and a column value, which are both integers. All right, so it has properties that what's the difference between a closed triangle for and an open triangle? Okay, someone is asking what's the difference between a closed triangle for inheritance and an open triangle. I really think there's a difference. I just closed that triangle because my diagram was really bad, but it's usually an open triangle. Yeah, just leave it open. You don't need to close. You don't need it. Yeah. Okay, so the question paper says that these properties, the row and column must be directly visible to all kinds of pixels. That means we make them protected, but other classes outside do not have access. That means only derived classes, so they have to be protected, which they are. Then the properties, they did not explicitly state constructors, but I'll put them there. I usually go with explicitly what they've stated, but yeah, let me just put them. So my class is called pixel. All right, so they all have a function called display that is then implemented differently. All right, so that's my pixel class. Then from my pixel, I have RGB pixels and BW pixels. So let's start with RGB pixels. An RGB pixel, what does it have? It has integer values, which are red, green, and blue, right? Then it also has a display function that it overrides. All right, so that was easy. Then I have BW pixel that has one property, its intensity. Then the operation it has is a display. Again, overrides the display function. All right, so that was easy. That was very similar to what we had in the previous question paper. So then let's say we have an image, right? An image which is composed of pixels. So the attributes it has, it's going to have pixels. It's composed of multiple pixels. So I will just keep them, I'll call them pixels, but it's basically going to be a list of type pixel, right? Then destructors. So I'll then it also has a display the various pixels. So I think if I'm right, that should be it. So it manages a life cycle, meaning it will have to create pixels, and once it creates it, it's going to store them inside here. So I think to be much more explicit, under pixel is going to be pixel pointer. It's going to have multiple pixels in a list. I'm just this is composition because it manages the life cycle. I'll change it. That should be it. And thank you. So if you have any question, just type it on Discord. We have about 18 minutes or 13 minutes or so, something like that. Yeah. We have 17 minutes. Yeah. So if you have any questions, just type this code. I'll respond to you. Apologies for the chat box muted and all that stuff.